what was the process? So if we worked with an inverse before, correct. If you had y equals 2x minus 1, to find the inverse of that, what would you do? You switch the x and the y, and then resolve for y. Everybody agree? So in this case, you'd have x plus 1 all over 2 is y. And there's your inverse. Right? What do you think changes with this stuff? Nothing. Nothing changes. Absolutely nothing changes. The only thing that's a little different is the fact that we're going to talk about natural logs, but the true definition of the logarithm itself, is that logarithmic form or is it exponential form? What is the inverse of log form? Exponential form. And that's all it is. So it's a matter of when you're writing these in terms of inverses, if it's in your generic log form, the inverse of that is exponential form. So let's see, what would that be? What is it? 9 to the y is x? I. You may use your calculator now. That's, by definition, that's really all right. The natural logs are where they get weird. Natural logs, when you're working with natural log, the inverse of a natural log is e to the x. Those are the inverses of one another. E and natural log are inverses. Excuse me. So when we set something up like this, we still flip-flop the x and y. And now we're going to get y by itself. What's the first thing you got to move? 3. Okay? So you have x minus 3 is the natural log of y. To undo natural log, you have to e it. And how you e it is you're going to use the e as a base, and the natural log is going to become the exponent. This is kind of like when I was talking yesterday about exponentiating something to get the exponent to drop out. We're going to do this. Yep. Because e, excuse me, we have e to the natural log. Those are inverses of one another, so the y value drops. You're done. That's it. That's it. Okay? It's not terribly difficult. It's just remember that e and natural logs are inverses. Okay? Now when we get to the other one, we're going to do the same process. We have x is the natural log of y minus 2. Since that y minus 2 is in parentheses, I can't do anything with it right off the bat. So I have to undo it. I have to undo the natural log. You e it on both sides. So you have e to the x and e to the natural log of y minus 2. When you do that, the e to the natural log, that y minus 2, drops. You wind up with e to the x is y minus 2. And now what do you do? Now you add the 2. Now the 2 doesn't go to the exponent, it's just plus 2 then. Okay? That's really the only two differences with natural log stuff. That's it. What's that?
It seems easy right now.
It is, and it doesn't get much difficult than that. It really doesn't. Instead of a 2, it might be a minus 2, it might be plus 3. Oh, I know, it's scary. Speaking of scary.
It's pretty good.
No. Take a number. I was called it a meeting, but shouldn't catch it. Make sure you're in radians, not degrees.
What?
Trying to throw you off. I might as well wait a second, give the next person their.
Yeah. Why do they get to use that calculator?
Yeah.
Oh, that's right.
It's not fair.
It is not fair. You're right. I totally forgot.
I feel like they won't even figure it out though.
Yeah, you're probably right. Here, put that one away. Oh, I'm sorry.
Wow, that was a really smart
No, I know. I like that side. I like the tie clip.
Yeah, I like the type of.
I like the great hands.
Weird, I really like that. No.
It's weird, I really like that, but I like, oh, I just fell off.
That doesn't really look exactly like her. It looks very similar, but it's not exactly.
Okay, cool.
Whatever's under that undershirt. Look. All right, graphing. Graphing. Graphing where things will start to get a little bit more involved. What's going to happen here with graphing is that log graphs all have the same things going on. You've got your log base b, y equals your log base b of your x minus h plus k. Now logs have vertical asymptotes. All right? Your vertical yes sir. It's still 8.4, yeah. There was no way I was going to get all this into one day. That's a lot. All right? Your h value is your vertical asymptote. Your domain is always, so your vertical asymptote is at x equals h. Your domain is always x is greater than h. Now, if x is always going to be greater than h, what direction will all of these graphs be going?
Right.
Correct. Up and right or down and right. They're going to be facing this way. Okay? They're always going to be facing that direction, towards the right. Now, it's only going to be moving one of two directions. If your base is greater than 1, it's doing this. If the base is between 0 and 1, it's doing that. Okay. The trick here is also, again, to be plotting these things without the use of a calculator. And what basically this works out to be is that you have to know how to create a 0 and how to create a 1 within the logs, in the bases. You want to know, remember, any base to the 0 is 1.
Yeah.
Any base to the 1 is the base. So you're going to be able to figure out relatively easy numbers just by slowly working through it. So what I want to start with here is
Wait, I thought they were going the other way.
up and right or down and right.
Oh, they're not opening to the right, they're opening to the left.
Moves up to the right, down to the right.
Down the right.
Yeah, did I say it backwards?
No, I already saw
Did I draw that back? I think I might have drawn it backwards now that you say that, because now you're looking at it. No, it's down and,
Yeah.
That's- wait.
No, when we were talking about it, we were just
Oh,
saying.
it's down and right, up
Oh, it's right.
and up and right. I was,
We were
I'm
just
thinking
saying like
okay.
this and.
yeah, I was thinking slope stuff. Sorry.
What?
Wait, but they
It's,
up and right.
no. I had drawn it backwards. I was drawing it via slope.
Oh,
Oh,
It's
wow.
moving, I'm sorry,
way to go.
it's moving up and to the right.
Now it's gonna change the whole.
I was doing it backwards.
Now I'm gonna.
And
Okay,
now
that's
it's
the
moving.
same thing you drew, except you just flipped them upside down.
It's not the same.
It's not the same.
Shoot.
I apologize. I was thinking, the way I was drawing it, I'm going, oh, up and right. So I was thinking,
Yeah, that's what I would've thought.
yeah, whatever.
It's not
That's why we have erasers.
I love that.
Taking notes.
So, plus now it makes sense to have the vertical axis put on that side.
I don't agree with this.
All right. So let's take a look at this y equals log 1/3. Let's take a look at this.
down.
We know that our base is 1/3. Okay. What is my value of h? It's 0. It's 0 because, do you see anything in parentheses?
Oh, no.
No.
That's the little trick here. Your h value is going to be 0, and your k value is -1. You okay with that?
Yeah, so we don't have an A value? No A?
No, not with this stuff.
Wait, what do you?
So as we get into this, excuse me, what we want to do is we want to figure out how are we going to create zeros and ones. What numbers are we going to pick? So what we've got here is a base of 1/3. And I want to create a log value that's going to be easily simplified. So 1/3 to the 0 power is what? 1. So if I'm choosing, excuse me, if I'm choosing x at 0, that means I'm doing the following. Log base 1/3 of 0 is 1. We okay with that?
Yeah.
Since there's nothing in the parentheses, I'm trying to make the x value turn it into a 0. Because b to the 0 is 1. Okay? So now if x is 0, what's my y coordinate going to be?
1. Log 1.
What are we trying to do?
0, because it's minus.
Let me start over here.
I know what we're trying to
Let me start over.
do. Confusing me.
We put this in tandem with this so you can see how this is working out. Our problem was a log-based problem. Our base was 1/3. Okay? There we go. The value of inside the parentheses is just x. Do you agree?
Yeah, because
Once-
wait, is it like shifting? Are we going to shift these?
When we do these, we go, this is the one graph that we're not going to do moving over.
But what
You're
about the
creating these values. What makes it 0, what makes it 1. That's how you get your two ordered pairs.
Weird, but there's x minus 1 in the equation. You just put like minus 1.
I'm doing that now. So for argument's sake, just for argument's sake, this is what our curve looks like. It's moving down and to the right because the b value is between 0 and 1. You okay with that? Okay. Now, how we're getting our ordered pairs off of this. So we move this over. Maybe. How we are getting our ordered pairs out of this is because we are figuring out what values of x are going to be easy to work with. Okay. You want to pick easy numbers to work with. So, take a look at what they're doing. If I go to my table, I gotta move up so you can see what's happening around the origin. Why is it an error at 0? Because that's your asymptote. You okay with that?
Yeah.
You have an asymptote at 0 because your H value is 0. We're all right on that? So that's why that happens. So if I put in my asymptote, there's my asymptote at 0. Now, just by looking at the next value in the table, you'll notice, where is it? When x is 1, you got -1 for your y coordinate. Think about why that happened. Think about why that happened. If you're using 1 for your value, it's because of this. Whatever your base is, the log base of 1 is always going to be 0. Log base 1/3 of 1 is 0. What's 0 minus 1?
-1.
-1. So when x is 1, y is -1. That's what they're using here. You're at 1 and -1. So you have an ordered pair at 1 and -1. You're picking ordered pairs that make this work. Okay? I'm going to choose x to be 1 because I know the log base 1/3 of 1 is 0. 0 minus 1 is -1. Okay? Now, the other one ordered pair I want to use is going to be that log base 1/3 of 1/3. Because what's log base 1/3 of 1/3? It's 1. Correct. So at 1/3, it was at 0 for the x value. Okay? Excuse me, for the y value, I'm sorry. So you have 1 minus 1 is 0. You're picking values that work into this. These are how you get your 2 ordered pairs. Okay? You're asking about the shift stuff. What'll happen is when you have the parentheses around this, you're going to pick a number that makes this into a 1. And I got an example here for it. Okay? Your range is going to be all real. Your range is going to be all real because you have a vertical asymptote. So your range is going to be all real. Your domain is always greater than your k value, or excuse me, your h value. So your domain is going to be greater than 0. Your range is going to be all real. Is anybody else a smart board when people are writing doing that? Have you noticed that a lot?
Well, yeah, you kind of writing behind the graph.
So your range is like okay. When you plot these, the only thing you have to give me is where is your vertical asymptote and 2 points. The curve itself is dependent upon if the b value is greater than 1 or it's between 0 and 1. You're either going to be going either 2 directions. Oh yeah, sorry, I have no internet yet. When you plot it, you only have to give you 2 points because anything after 2 points is just going to be a nightmare. You're not going to try and go through all that. I mean, you could use 9. Log 1/3 of 9. Isn't that 3, I think? Yeah, I think that's how it works. It'd be stuff like that. You're picking out values like that. Wouldn't be 9. 1/3 power. Well, I would use something better than that. I would use 27. Because that's 3 cubed. You know what I mean? Things like that.
You're never going to put 27 on a graph.
Right. But that's how you can pick out ordered pairs. All right. Take a look at this one. In this one here, I've got log base 5 of the quantity x plus 2. So my base is 5. My h, what's h?
-2.
Good. H is -2. K value is 0. Okay. So my vertical asymptote at x equals -2. I know my domain is going to be x is greater than -2. My range is all real. I know that just from that information. All right. So now I go ahead and start thinking about what am I going to pick for points. Here's my vertical asymptote. My b value is greater than 1. That was the underside, so it's going to be going up and over. Okay. So again, I want to pick a b value, or I want to get a value to make this into 1. I want to turn that, yeah, so I use what? -1. So if x is negative, sorry, I had to think about it, like, wait, huh? Everybody see what we're going to do here? We're going to pick, I want log base 5 of -1 plus 2. That gives me log base 5 of 1, which is 0. So that means my ordered pair would be at -1 and 0. You okay with that?
Yes. So,
Michael, log base b of 1 is 0. I want to create what's in that parentheses and make that into 1. What do you add to 2 to make it 1? -1. So that means that when x is at -1, the parentheses becomes 1, which means it's 0. We're simplifying ahead of ourselves. Before we would set this up with a generic idea and then shift things over, but with logarithms, we go back to just these 2 points. Okay? Exactly. Everybody see what the next point's going to be? 3. The reason the next one is 3, I want it to be the log base 5 of 5. So when I use log base 5 of 3 plus 2, that gives me log base 5 of 5, which is 1. So at 3, it's at 1. And it's doing this. So my ordered pairs, my 2 ordered pairs, were at -1 and 0, and 3 and 1. Is some of the confuddleness?
yeah.
X put it in the number you put in, and then Y put it in the number, that's what that happened.
Yes. X is your input, Y is your output. Okay? It's going this direction because the p value is greater than 1. It was going this direction if it was between 0 and 1. And those are the only 2 scenarios we're going to have. Because you're bounded by an asymptote that's vertical. So it's always going that way. So it's either going to be going down that way or up that way. Okay? Man? Yeah. I'm going to do another one. Let's say 1/2. I'm trying to make this not terrible.
+1?
+1, yes. That should be okay, right?
So when you try and make, let's say you try and make it equal 1, so I put 2 for x, or would I put 1? Because you have to +1.
You want to make the parentheses, you want to turn this into a +1.
Yes.
So what do you want to make x be?
3.
3.
Alright.
Okay? And this is what's weird, because you're trying to create this scenario.
Would you then add something?
Then you would add 1 to it. Correct. All right. So in this case here, your b value is 1/2, h is 2, k is 1. So your vertical asymptote is at x equals 2. Your domain is going to be x is greater than 2. Your range is all real. Again, straight from the equations, we know that. Okay? Straight from that, we know that to be true. When I go to pick out points, that's close. Got my vertical asymptote at x equals 2. Wait, what?
Never mind, I just got done solving it. Shouldn't it be like facing this?
What's your b value?
Negative.
It's not negative.
I mean, it's less than 1.
So it's less than 1, so it should be doing this.
But the first.
Oh,
no.
hold on.
Yeah, that's what I thought.
Yes. Sorry, I'm looking at it upside down when you did it towards
No, I
me.
know, but the points that I have don't reflect that. I don't know if I got the wrong points. Can you just figure out the points?
Well, let's look at it. We want to use, what are we using to start with?
3.
3.
And then you get 4.
So at 3, if we use log 1/2 of 3 minus 2 plus 1. This means log base 1/2 of 1 is what? 0. What's 0 plus 1? 1. So it'd be 3 comma 1.
Yeah.
Okay? That looks okay. All right. Now, the other one I want to use, I want to use something that'll get me to 1/2. 2.5. Okay? So at 2.5,
So it's at 2.
I have log base 1/2 of 1/2, which is
1.
1. 1 plus 1 is
2. I
2.
forgot to add the 1, and then I had, yeah, that's for you.
So it's happening here. And that makes sense that it's dropping then.
Yeah, I
Okay.
forgot to add the 1 so that.
So it looked like it was going the other direction?
Yeah. I was like, I hope that's right.
And these are going to be a little bit weird. You just have to remember the idea that you could get these little halvesies in between because you're really only going for 2 ordered pairs.
Yeah.
That's all I'm looking for in these things is 2 ordered pairs on this. Okay? Let me do something like that. Yeah, so it was 2.5 and 1 was the order, or sorry,
2.5.
2.5 and 2, and then 3 and 1. Okay? Everything just keeps going back out of that. Let's do another one. Well, that's a lot tougher than ones that Bookie gives you.
Feel bad for Joe because he ran it back to his locker to get his calculator.
Let's do this.
No.
I'll do one more.
It was like on the non-calculator part. Yeah.
Okay. So we started again. We have log base 5 of x minus 4. So my base is 5. My my h is 4. I have no k value. So my vertical asymptote is at x equals 4. My domain is x is greater than 4. My range is all real. And since the b value is greater than 1, it's going up, over. So if you want to make this sketch next to it, that way it helps you remember what way it should go. All right? So now you want to create these 2 scenarios. I want to create log base 5 of 1. So what does x have to be? 5. Good. So the first one I have will be log base 5 of 5 minus 4. That gives me 1. So my ordered pair is at
5 and
5 and 1. Oop, forgot to draw my graph.
Wait, when it's one log
Would it be zero?
base down and
Then sorry, jeez, don't yell at me for Pete's sake. Somebody said 1 and I just believed them. I'm sorry.
Well, you said, you were like.
Whatever,
it was
nobody's
one.
listening to you.
Alright. Alright.
All right, so we have our vertical asymptote at 4. Okay. Our first ordered pair is at 5 and 0. Now I want to create the log base 5 of 5. So what's the next one's got to be at 9.
9.
So log base 5 of 5 is
1.
1. So this ordered pair is at 9 and 1. Did I get that right before you yell at me?
Yes.
There you go.
No, I still will.
Not so bad?
No.
Do you like them, Austin? I do.
Let's do these then.
And I haven't thrown it. That's all I got. Okay. I missed Austin. I missed you.
No, don't do 65. That's too easy.
man.
Feel great.
So it's basically 67 through 75 odds. Because I'm not going to worry about graphing natural log. That just gets to be. You guys have graphed
67 or something?
Yeah, just go 67 through 75. Yeah, because the first one is log base 5 of x.
Sweet.
So there's really not much you have to do on that one. All right? Remember, list out your stuff like we were doing. Label your asymptotes. Draw them in. Seems to be a forgetful thing a lot of times. Put those in. Pick those ordered pairs that make it work cleanly, all right? Questions? It's just in that pile right there, Joe. Your friends around you didn't hook you up and take care of you because they must not like you. I am sorry for your friends. Yeah, he was barely awake, so, yeah.
Joe, did you know that there's a calculator and then it was not?
No, I needed it for the.